Okay, example 5 says find the exact value of the sine, cosine, and tangent of alpha over 2, given that cosine of alpha is equal to 24/25 and alpha is in quadrant 4. Alright, first up, it's the same kind of problem we've already seen with the addition or the sum of difference identities and the double angle identities. They give us some information about an angle or angles. They tell us what quadrant it's in, and they ask us to perform one of these identities, right? One extra added feature for alpha over 2 or x over 2, whatever they're going to call the angle, when you deal with sine and cosine, is that whole plus or minus scenario, right? So let's focus on that first. They're going to tell me where alpha is located, in quadrant 4 in this case, or they might say it's between two things. 270 is less than alpha is less than 360. Pi over 2 is less than alpha is less than pi. They'll tell you something like that. All right? So imagine if alpha is in quadrant 4, if we look at an inequality representing that. Put alpha in the middle, just a basic conjunction, something less than alpha less than something. Quadrant 4, if you look at quadrant 4, it's down here, right? This is 270 degrees and this is 360 degrees. So if alpha, if we're measuring around somewhere to get alpha, right here, it's between 270 and 360. So we're going to write an inequality to represent that fact. Okay, sometimes they give you the inequality, sometimes you have to make it yourself, but each of the quadrants can be written in that manner. So the small version, or the small number, is less than the angle, is less than the big number. That's how you write the conjunction. Once you've done that, the angle we care about is alpha over 2. So if I want this to be alpha over 2 in the middle, how did I do that? I divided by 2, right? Right? So I want to divide everything by 2. So 270 divided by 2 is 135, and 360 divided by 2 is 180. And if we can consider that this is 90 degrees straight up and this is 180 degrees straight left, and 135 would be up kind of like this, that's 135 right there. They're telling me alpha over 2 has to be in between these two angles. Alright, so we have the ability, and if alpha over 2 is between 135 and 180, that means alpha over 2 is going to be in quadrant 2. And in quadrant 2, sine is positive, cosine is negative. So it's very important that you have to establish what quadrant these things are in to get the correct sign on your answers. Alright, tangent, don't have to worry about it because tangent sine comes out exactly right every single time. No fuss whatsoever. But sine and cosine are a little bit picky, hard to get along with, so that's how you have to deal with that. But again, simply identify the conjunction representing the quadrant, take half of everything, and this will put you whatever quadrant you're going to be in. All right? Next. So all that stuff got me this information here, and I'm going to erase all this stuff because it's in the way. Now, the next thing we want to do is what we have been doing on these problems every single time. A couple of us aren't doing this on our homework, so make sure that we're doing this step here. I want to draw quadrant 4. I don't care so much about quadrants 1, 2, and 3, but quadrant 4, I want to have some room down here to draw it. And I'm going to draw a vector down into quadrant 4 that represents alpha. So there's my vector. And I'm going to draw a vertical line up to the x-axis from the end of my vector like so. And that creates a right angle there. Alpha is going to be the angle, we're looking at reference angle alpha to represent our alpha. The only reason it would be important to measure counterclockwise around here is to get the correct sign and everything. As long as we establish the correct sign in our triangle, the reference angle alpha will suffice as alpha. All right. The cosine of alpha is 24/25. That's adjacent over hypotenuse. It's a positive. This is always positive, the hypotenuse is. And we're going to the right for this dimension, so obviously that's positive. And the Pythagorean triple, we've seen this quite often in the homework, 7, 24, 25. But since this is going down, it's a -7. So we can very easily identify our triangle in the correct quadrant with the correct signs on the horizontal and the vertical legs. The hypotenuse, again, is always positive. And once I've got alpha drawn correctly, then sine of alpha is equal to opposite over hypotenuse. Cosine of alpha, I'm trouble drawing alpha today. cosine of alpha is 24/25. I could, if I felt like it, put down tangent of alpha, but none of my half-angle identities involve tangent, right? They're all about sine or cosine, so just having that down is sufficient for this. All right. So, if I want to do sine of alpha over 2, it's simply going to be the positive square root of 1 minus cosine over 2. And just apply the formula, substitute 24/25 in for cosine, because that's what cosine equals. All right. If I multiply each piece times 25, it's going to get me the square root of 25 minus 24 over 50, which makes the square root of 1/50th. Now, the top this time's a perfect square root, the bottom isn't. All right, there's no like rhyme or reason to this. Sometimes neither one will be a square root, a perfect square root. But what I want to bring to your attention is this. I want the bottom to be a perfect square root, right? So what we can do is we could go ahead and make it simple as possible at this point. Or if I just look at this and multiply the top and bottom by 2, the bottom becomes the square root of 100, right? So just using a little bit of thinking, I can figure out if I multiply by 2, I make 100. 100 has a perfect square root. So that gets me sine of alpha over 2 is equal to the square root of 2 on top over 10. And just like that, I've got the sine of alpha over 2 figured out. If I move on to cosine of alpha over 2, same idea. Cosine of alpha over 2. This time it's a negative square root because we've already figured out we're going to be in the second quadrant. Second quadrant cosine is negative. The identity tells me I'm supposed to do 1 plus the cosine of alpha divided by 2. Multiply by 25, multiply by 25, multiply by 25 is going to get me the square root of 25 plus 24 over 50, which makes 49/50, right? Once again, 49 is perfect square, 50 isn't, but if I multiply by 2, multiply by 2, I get the square root of 98 on top and the square root of 100 on the bottom. And notice, and I forgot this, see that minus sign? Still minus, still minus. Don't forget about that minus sign, it's very forgettable. Forgot about it first period when I taught today too. Remembered it later just like I did now. My own mistakes. But whatever sign's there keeps coming along. And then the square root of 98 is 7 times the square root of 2. The square root of 100 is 10, and it's negative. So the cosine of alpha over 2 is equal to that. Finally, we want to do the tangent of alpha over 2. It is 1 minus cosine of alpha over, or alpha, over sine of alpha. So that's where sine is necessary to find tangent. So 1 minus cosine is 1 minus 24/25. Sine is negative 7/25. Multiply everything by 25, I'm going to get 25 minus 24 over negative 7. So that ends up equaling negative 1/7 is tangent of alpha over 2. One extra added little feature I'm going to show you here, just a thought. It's not very hard to do this, right? But if you've already gone to the trouble of finding sine and cosine and tangent sine over cosine, right? So I could have also gone tangent of alpha over 2 equals the sine answer, which is the square root of 2 over 10, over the cosine answer, which is negative 7 square root of 2 over 10. They're both over 10, so multiply top and bottom by 10 gets the square root of 2 over negative 7 times the square root of 2. Square root of 2 is canceled, negative 1/7. That always works. So if you have to find all three, I don't have a problem with you just finding tangent that way. But if all you have to do is find tangent, it's easy enough, just use the identity. If if you have to find all three, if you've already found sine and cosine, by all means, if you want to do it this way, that's fine. I do want you to practice this occasionally, though, just to make sure you have that in your bag of tricks when you're trying to do these problems. All in all, again, they're the same kind of problems they have been. This is necessary to create these answers and then apply the proper identity to find what you're looking for. And again, identifying the quadrant of the angle you're looking for lives in, that's the only added step to this that the other ones didn't have before.